we are starting a new series. Um, neighboring. We are doing daily lead code, and we'll solve the lead code daily problems every day, and that's the plan, or whichever day I find time. Um, Probably do it throughout life. So this is the plan, and let's see what is today's question. A zero index array derived with length n is derived by computing bitwise XOR of adjacent values in a binary array original of length n, specifically for index I in range 0 to n minus 1. If I is the last index, then derived of I will be last index, XOR of last index and original. Otherwise, the derived of I will be original of I plus 1. Okay, makes sense. Given an array derived, your task is to determine whether there exists a valid binary array original that could have formed derived. Okay, cool. I have no idea how to do this. Let's try to see the examples. So derived 110 will be true. What would be 111? Let's say. Let's see the example one. So this could be formed by 010, where derived of 0 will be original of 0 into original of 1. So 1, 1, and 000. Cool. 1, 1 would be also true, which could be followed by 0, 1. 1, 0 would be false. Why? 1, 0 would be false. Can it be formed by 1, 1? No. Can it be formed by 1, 0? No. Can it be formed by 0, 1? Nope. Can it be formed by 0, 0? No. So, yeah, this is false. Okay. So, what will be the answer for 111? 1, 1. Can I find the original out of this? So, this one could only be formed by a 0, 1 or 1, 0. Okay. So, 1, 0. Either the answer would have something like this or 0, 1. Or the answer would start from this. Okay. This one, if we take this one, so either the answer will be 1 or 0. Cool. When we come to this one, then either this will be 0 or this will be 1. So will this form answer 1, 1, and 1? Cool. Yep. If we have four ones, let's check out four ones also. In that case, we'll have to add another one, but 1, 1 will not be. So I can see a pattern. I can't actually. Four ones. Four ones. Okay, four. Okay. For 111, for 111, 111 cannot be an answer, no? 111 cannot be an answer. So I can see a pattern for every two ones, there should be one zero. One zero is not possible. The two ones are possible, but three ones are not possible, I think. Are four ones possible? Are four ones possible? So one, one, and one. So four ones are possible. So zero one will give us one. One zero will give us one. Zero one will give us one. One zero will again give us one. Four ones are possible. So there should be even number of ones. There should be even number of ones followed by a zero. How many zeros can there be? Zero, zero, followed by any number of zeros. It is not a problem. Cool. I think we have our answer. There should be even number of ones. Then any number of zeros could come. So if I have, let's say, 1, 1, 0, then the answer would be 101 or 010. Both will be the answer. If I add one more zero, so this would be one. This would be zero. So one. So this also works. If I add another zero, that will also work. If I have a zero at the start, if I have a zero at the start, so from zero here, I will have to start from a one. One, zero, one, one, zero, one, one, zero, zero. That works. But if I have 0, 1, 0, can I make that 0, 1, 0? For making 0, I will have to use 0, 0, or I will have to use 1, 1. For making this 1 with this, I will have to have 1 here. I'll have to have 0 here. And then again for this 0, I will have to have 1 here. For this 0, it cannot work because this will not work. This will not work. Okay, good. But let's say I have a very bigger string. I I think there should be some problem. 0. Will this work? This does not work. Does this work? Yeah, this does work though. This does work. So I can't do this very greedily. Uh, so 0, 0 row will give us 0, 0, 1 will give us 1, 1, 1 will give us 0, 1, 0 will give us 1. And that fails our logic. So we can start building the, I think we can do a proper DP, I guess. So the answer for, we can calculate the answer for every position. So we start with a 0 and 1, and then for 0 we will have 0 or 0, which will be 0. For 1 we will have 1 or 0, which will be 1. For 0 we will have 0, which will be 1. At the end, when we are at this point, we just see if the first position and that match. If they match, we return true. So I guess that's how we can do it. See a way. So let me just write it and return solve of I, comma, an array which has 0, or solve of, so 0 comma 0 comma 1. Okay, so initially this will be the case bool solve, okay, int I comma int vector int v. Okay, now if I is equals to n minus 1, return of I is equals to v of I XOR v of 0, else now return ah, solve of I plus 1, comma T dot push back V dot back XOR derived of I. This dot derived is equals to derived what should I do? Vector and derived int n is equals to derived dot size. I think that's enough. Let's see if that works. 0, 1, 2. N is 3. 3 I is equals to n minus 1. That is that we should go here. Uh, why does not why doesn't this work? I is 2. So it should go here. If I is equals to n minus 1, what is n? Oh, n is 0. N is 0. Array. Oh shit. This works. No, I think I can optimize it. Let's see if it submits. Should I submit it right now? Or should I just first optimize it? Because it seems easy. Easy peasy. Let's see. This is a OMFN solution. Memory limit. Yeah. I thought that that would be a problem because by using a vector, we can remove this vector totally. We can also go in an iterative way. So for int I is equals to 0, I smaller than n minus 1. I plus plus. Cool. That pushback. Is equals to 0. Yep. This will also have memory problems, but kind of better. Though it's not very well. We can even optimize it even more. So let's do that. Uh, so we start with 0. We start with 0. We need to XOR all the elements and check if it is 0. So we need to XOR all the elements and check if it is 0. Mhm. Yep, that works. Now I can remove this, this, this. And it's equal to derived dot size. Cool. I think we have a fully optimized solution, and it was not that difficult. How much time did we take? We took 24 minutes. I'm happy about that. So yeah, uh, can we do something better? Like, why is it not 100% always? Like it goes to 100 sometimes. It's not always 100. Cool. I think that's enough with this. Yeah.